Okay, here's example 3 for BB13, match quadratic functions and graphs. So I want us to first notice that for each one of these equations, our A is 1 for each one of these. All positive, all the graphs are facing upwards, so we can't actually use the orientation as something to determine between the different graphs. So just like our last video, let's start marking down what our C's are. This first one is already in standard form, so we can see that our C is 5. Our standard form is here for the second one for g of x, and we can see our C is 9. For h of x, here's our standard form, and for k, here's our standard form. So let's go ahead and mark up those C's. So again, we said C was equal to 5 for the first one. For the next one, C equals 9. For h of x, the C equals 21. And for k of x, the C equals 9. So we do have an overlap of C's for g of x and k of x. So that might not be the only information we need to determine which graph goes with which equation. I want us to also notice that we have been given some vertex forms. Because g of x is a perfect square, we have our vertex form here for g of x. H of x is one that we're going to ignore like we did on our last video because this is actually in that intercept form that we discussed. And for k of x, because it's also a perfect square, we have our vertex form. So let's go ahead and figure out our vertex for g of x, because that's what's going to distinguish between g of x and k of x. Remember that our vertex form, our vertex is the h and k. So our vertex form is y equals a x minus h squared plus k. Move that out of our way. So if that's the case, our vertex is hk. It's going to be the opposite same for what's in here. Because nothing's being added to our x minus 3 squared, we know that our vertex is at 3, 0. Because notice we've got minus 3 plus some 0, that's our vertex. For this one, it's just going to be the opposite sign. So we're going to have negative 3, 0. So we should now have enough information for us to determine which equation goes to which graph. So from here, let's go ahead and start making the distinctions. For f of x, c equals 5. So let's go ahead and start looking at our y-intercepts. Our y-intercept for our first graph here is up at 9. So that could be g of x or k of x. Our y-intercept for this next graph is somewhere on the equation that we can't see, so it's greater than 10. For this third graph, our y-intercept's at 5. And for this one, our y-intercept's at 9. So we can already tell ourselves that the f of x, or our x squared plus 5, has to be this third graph. So I'm going to go ahead and put this one with our third graph. We can also see that this next graph has to be the one that has our y-intercept at 21 because it's above 10 and we can't see it. So I'm going to drag our h of x into that second one. Now we're going to use our vertex to determine which of these are each other. So recall that our vertex, in this case, since we open upwards, are our minimum points. These are our vertices. So if we're looking for those particular points, this one is at negative 3, 0, and this one's at positive 3, 0. So that's now enough information for us to figure out the last one. So the positive 3, 0, or the g of x, is going to go here with the one that has the positive 3, 0 vertex. And our last equation that had the y-intercept of 9 and a vertex of negative 3, 0 is going to go with that first graph. I really hope this helps you guys, and you see this screen.